And that 35.968 of the of argon-36, that's how much it weighs, is 0.003365. All right, hold the phone there. What did I do? I took this percent abundance and moved those two places to the left. Now, is that a lot of atoms? No. I mean, it's a minuscule amount. It's measurable. It's there, but it's minuscule. The same, I mean, more so with this one here. All right, 37.963 times 0.000. What's next? 632? Is that right? Okay. And then the next one is 39.962 times 0.996003. Now you can see there that naturally the biggest contribution would be there. And if we want to use our school analogy, you know, you would have one test that was worth 99.6% and the other test would be worth this. Basically, you would not even have to show up, right? I mean, who would show up to try to get points on something that's worth less than 0.1%? I mean, that's ridiculous, all right? It wouldn't even be worth the stress of taking. But naturally, the 99.6. And what did you guys get, you said? 39.947 AMUs. What does the periodic table say? They probably rounded off at what, 39.95? All right. It depends on what periodic table you're looking at and what type of work you're doing, where you would round that off at. All right. Anybody got any more questions? All right. So where have you saw and heard about this mass spec idea? Does anybody know? Nobody knows? Well, anytime you watch a show like CSI or one of these crime shows, forensics, they always talk about a GCMS. That stands for gas chromatography mass spectrometry. And that is a way, what the GC does is separates out the different components. So a GC will tell you that there's 18 things there, okay, as an example. And what a mass spec will do is it will identify all of those 18 things, all right? So in other words, every chemical has a fingerprint based on these masses. All right. So let me see if I can look up something here really quick. Let's look up that. All right, that's not what I wanted. Just to show you what I'm talking about here. So what I'm going to Google is I'm going to Google something called THC. All right. And then I want to put in the chemistry abstract number 1972-083. Somebody remember that? Well, I'll just type in C21H30O2. All right. C21H30O2. And if you take me for organic, you will see that different ways to do this. Here we go. All right, let's take a look at the mass spec of this guy. All right, maybe, if it will pop up. Here it comes, I hope. All right, so you see that right there? That's a very complicated series of lines, but what's on the axis here? Mass. These all come from atoms, What are these right here? This is a relative abundancy, or the percentage. So this is a characteristic fingerprint, and back years ago what would happen is the mass spectrometrist would sit down with a ruler and a calculator, and they would do this. Now what happens is there's computers that match these points, and guess what's really cool, and this holds up in court with greater than 99.99% confidence, that if there is pot or marijuana in your pee, this is what it's going to look like. There is no second guessing that. All right. So this is a common way to drug test, do forensics, try to find out what's killed somebody, try to find out what's in someone's skin, flesh, and the like. Why am I talking about this now? Well, what's the technique based on? How much the atom weighs and the isotopes in it. All right. So like bromine, for example, has characteristic patterns. I can tell as a mass spec guy that this does not contain bromine. All right. I mean, this is not the class nor the time to get into that, right? Organic 2 is. We get into it for 3 or 4 days. But you can just look at this, and to a chemist, I mean, this brings out a picture of what's going on. All right. So I just want to show you that that's another example of the way this stuff come up. Who's been drug tested here? Anybody? A lot of people. Do you guys know how that's done? At all? Drug testing? No, nobody knows how it's done. Well, a lot of times how they do that is you'll pee in a cup, and they have what's called a panel. So by a colorimetric technique, they may have a 5-panel, a 3-panel, or a 7-panel test. And they'll put drops of chemicals in the urine. If it changes color, all right, that does not necessarily mean you've been smoking pot. They will now take your sample and send it off and run it on a mass spec. Does that make sense to you? That's what's called, does anybody know what that's called? A false positive. All right. So like if everything turned clear, you're clean. You ain't been doing drugs. If something turns color, you may or may not have been doing drugs. It's inconclusive, you know, you don't know. So they send it over here to the mass spec boys, and we run it, and we can tell you for sure if you've been doing it or not. All right, that's non-negotiable. What's the difference? 15 bucks, $80. All right, so most chemical or most employers will pay for this right here first. All right, and hope we don't have to go there. Yeah.
What else can make it change color?
Who knows? Who knows? Sometimes it's nothing. There's so many components in urine and things like that, it's just hard to find out. I mean, there's all kind of various things that go on, hormones and so forth. Yeah.
If you're pregnant,
I'm not really sure about that. I think every person's a little different on that. Yeah.
We get our waste samples out of the base.
Mm-hmm.
Some of them can be as much as $3,000 if we're just testing for volatiles or semi-volatiles.
Oh, semi-volatiles on the mass spec? Oh, yeah, that's high dollar. Yeah, anytime you got to hook up things that are called purging traps for volatiles, semi-volatiles, PCBs, all of this type of analysis, oh, yeah, you can get into high dollar technical stuff.
Just the standard metal is about $250.
Now, how they do metals is probably, I don't know, the technique they use is something called a graphite furnace AA. It's a little different than that. They burn it and look at the color it gives off. But anyway, so that's cool, right? Is that not cool? Nobody here cares about drug testing, right? Just wanted to tell you that that's just something that's come out of this topic. Does anybody have any questions about this chapter? Are we good? At all? Alrighty then. Well, I am done until next time. You guys seem like you got it. Be sure to work these problems.